Using what we've learned about fluids, I want to apply it in one of the early applications, actually, that sort of surprised people. The idea is that you set up a pump by having a very low pressure here, low pressure for an open air type well, and you basically treat it like a saw, like you're sucking the water up. So you have low pressure here, and then you basically are using the atmospheric pressure that pushes the water up and through the pipe. And so right here, this pressure, which is at the same level here, is going to be P0, or 1 atmosphere. And so the question is there a limit? And it turns out there is a limit, because this lowest pressure we can have is a pressure of basically 0 pascals. You can't actually get to exactly 0. You can get really low, though. So we'll call it 0. And then that tells us sort of this height, right? Because our height tells us that if this is a pressure of 0, pressure equals 0 up here, then the pressure down at the bottom, let's see, we'll call that pressure at the bottom now. Pressure at the bottom of this needs to be 1 atmosphere, or 1.01 times 10 to the 5th pascals. And so what that says is that the pressure at the bottom equals this P at the top plus rho GH. And pressure at the top is going to be approximately 0, low pressure at the pump end. And we need the density of water, which is 1,000 kilograms per meter cubed. G is our 9.8, and we can find our H. So we've got 1.01 times 10 to the 5th pascals, which is newtons per meter squared, just so we can check our units. So we've got times is equal to 1,000 kilometers per meter cubed times 9.8, that's our G, meters per second squared, and then our H. Okay, so kilogram times meters per second squared is newtons, so that can all go away. And then I've got a meters cubed divided by meters cubed over here and a meters squared over there. So I'm going to divide this whole thing now times 10 to the 5th per meter squared, all divided by 1,000 times 9.8. And then we're left with meters cubed. So the units actually do work out. Notice that this is just a unit of H, and that's really close to 10. If we call this a 10, then this is essentially 10 to the 3rd, and then 10 to the 3rd, and all of this is very close to 10 to the 4th. And so that's a height of right around 10 meters. Let's find out what it is exactly, though. So that's 10.3 meters, or about slightly more than 30 feet. And that's really as deep as you can pump from a well with a pump set up like this. Now, there are other ways to get things going. You can have pumps spaced along the way. You can have things that are not open air, that are sealed so that the pressure is higher on top of those. So this was a surprising result when people first encountered this, but it doesn't keep us from pumping water out of the ground.